Okay, in my last video, I talked about creating this code. We tested it out. We're going to do a little bit of fine tuning. I think it possibly overshot it just a little bit. I'm going to scale this back to 80.86. And then I'm going to change this if it's less than 60. Now, with this code here, this is what it looks like in Robot C. The graphical version will look like this. Basically, you grab an if-else block and you drop it in the repeat until. So you get that gyro heading, gyro sensor, and I'm putting repeat until it's greater than 86. If it's less than, and what did I change it to? If it's less than 60, then we do turn right 20 degrees at 20% power. Otherwise, turn right 10 degrees, 10% power. So we're saying as long as we're close, if we haven't turned 60 degrees, go a little bit faster. But as soon as we get closer, so we're within 26 degrees, we slow it down to finish the turn so that it's less likely to overshoot our target. And this 10 degrees is of a rotation of the motor. Okay. Now, the other thing I mentioned is I showed you how I calculated how to drive forward 709 degrees. Well, I decided doing this calculation is tedious, right? If I have to do that calculation, which is over here, if I have to figure this calculation out over and over and over again, every time I have a new distance I want to go, this could become cumbersome. So I decided to write a computer program to do this automatically. And I did it in Python as a way of testing. So let's go ahead and test it out. So I'll show you this program. And then we'll convert it and we'll actually create a function inside of Robot C. However, I'm only going to do it in the text version of Robot C. I will not do it in the other version. So now I'm going to write a function right at the top before task main. And honestly, yeah, as long as things are turning blue like this, it means it recognizes that term. Usually when you write a function, you have to determine whether it's sending out a value and what kind of value. So our degrees are going to be in integers. So I'm going to write int because it's going to send out an int. And then I'm going to write the name of the function. Now I need to get my Python code in here to get it to work. Okay, so I'm going to use this as a model for it. I'm going to rename it a little bit. I'm going to call it get degrees. And then I think I have to determine the data type. I'm going to put double. Double is a type of floating point. And it's distance. So I want to be able to give an exact distance. Okay. And then I'm going to write this down here. Oh, it looks like in Robot C we need to do it this way. All right, here we go. Okay, so double, probably not as important. I'm just going to write float. Okay, now get degrees. So let me get my calculation here. We've got a variable called degrees. And, oops, sorry, wrong one here. And so we're going to put rotations. Oh, I have to determine what kind of data type rotation is. We're going to do float rotations equals distance divided by pi. Turns out you just write pi like that. Times diameter. But I don't know what the diameter is. So I'm going to have to set it. I'm actually going to set the diameter up here. And I said 2.75. Now, what I'm doing is I'm creating a variable, calling it diameter. I'm setting it up here, which means my function can know what that number is. My task main can know what that number is. All right. I'm going to double check, make sure it works on a compile. It doesn't like this, and I know what it is. I'm pretty sure my error is I'm not returning it. No code generated, not valid. Let me just see if I can find this. All right, I figured out the issue. You don't have to write function. You just put whatever it returns. So it's int, get degrees, float distance, return rotation. Now, I'm not done with this. I just wanted to test to see if I'm doing it the right way. I'm probably going to need, I'm going to make this a float anyway, just see if that works. I don't know if it's going to work or not. All right, so it's going to return a float, get degrees. We'll see if we can get this to work. Let me get the rest of the code in here. So once we get rotations, we need, I'm sorry, we're going to do degrees. So we're going to write float degrees equals rotations times 360. That's one way we can do that. And it's return degrees. That should work. Or what we can do is we can condense this to basically take this argument, and multiply that by 360. You might want to take a look here. When I set this variable called diameter, I could swap out my wheels, measure the diameter of the new wheels, plug it in here, and it should work swapping out those wheels. And if you want, I can try it out and see if I'm right. All right. Yeah. All right. I'm getting cocky here, so I better make sure this works. Then we write this function called get degrees. We give it a distance, how far do we want it to go, and then we return the number of degrees it's going to have to turn following this formula. And when we go to call it, instead of going forward and writing the number of degrees, we run this function get degrees, and we pass it the number 17, because that's how we know how many degrees we want to go. Okay. Now, we're going to apply it. Remember, I changed that to 19, didn't I? So I'm going to change this to 19. And then I'm going to turn forward 9.5 inches. So now, watch what I do. It's just forward. And it's get degrees. I'm going to put 9.5, comma, degrees, comma, 30, like so. Hit enter. Let's see if this works, and we'll test it out. So I'm going to go ahead and save the program, and then I'll test it out. Okay, when I did it, it was a complete fail, and the reason why is what I did here. I need to do order of operations, so what I did a quick fix. I multiplied pi times diameter first before I divide it from distance. So I do that first, then I multiply by 360. Now let's test it out. But by the way, once I get this thing working, it's working, and then from here on out, I don't have to think about that anymore. I can just focus on putting in the right numbers. So let's just see if that works now. This time I'll record it and show you the results. Test this. I'm going to go ahead and test this out. It's actually running, see? And then I'm going to press that button if I can find it. There, see, I went 2 more inches. See how it got out there a little better? Let's see if that 9.5 works. Okay, I think I got it working now. This should be working. Looked good there. So I'm going to take what I learned and apply it now to the last turn left 90 degrees. And by the way, here's something we can do. We can take this and make it a function also. Yeah. So let's just go ahead, and I'm just going to copy and paste this in here. And I'm just going to paste it in. Oh, I don't need that. And then I'm going to go ahead and, what did I say? Did I have another turn or a forward heading? No, I didn't. I'm just going to go ahead and add this piece here, just to see if I can get it to work. Save my changes. We'll upload it, test it out. Now we're ready to begin. Press the button. Let's see if it works. By the way, part of the thing we can do is we can test to see how reproducible this is. Like, how many times can I do this? Oh, crud, it didn't turn. Well, fortunately, I have some very intelligent students who are able to quickly identify what went wrong. Part of the problem is I never reset the gyro sensor. All right, so there's a couple things we can do. is I think the best thing is to do that reset of the gyro each time. I'll put a first reset gyro, and I'm going to test that out. I'm not even going to use it on the course. I'll just see if this works or not. Okay, one final step, and that is I'm going to convert all this code into its own function that will make it so it's a lot easier to turn right or turn left. And so it's even going to include the resetting of the gyro, so I don't have to do that every time. And we'll have some really clean looking code at the end. So let me do that now. Okay, so I've renamed my program Modular Maze Code. I call it modular because I'm creating these little modules to do what I want it to do. We already went over the get degrees, but let's talk about how we did the right turn, and then I want to talk about left turn because that actually took some work to get to work. It says void here. Void means that it's not sending out, it's not returning a value. Like in this case, we're returning degrees. Since we're not returning anything, it's void. It's like this void where nothing comes out of it, and that's okay. Because basically, we're going to still program the robot. We call it right turn, and we give it a number of degrees. How much do we want to turn to the right? Now, we made it an integer, and I suppose I could have made it a float, but I didn't, so there. We're going to keep it as whole degrees. And so there's our resetting of the gyro. And then we have this little adjust degrees for plus or minus 3 degrees, depending on which one you're doing. We turn to the right. We decide, let's take degrees. Let's take 3 away because it's a little bit off. And then the rest of this should look very, very similar. So the key is resetting the gyro and setting this little thing here to adjust for problems. Then we have this repeat until the gyro sensor is greater than the degrees, because we start at 0. If we turn to the right, we add degrees. So we go until we're greater than degrees. And then we do the same, get the gyro heading. And this is, remember, this is our target degree. Take the target degree, let's subtract 30 from it. So when we're within 30 degrees of turning of our target, or until we turn right at 10 degree rotation of the wheels at 20% power, until we are, whatever our target is, minus 30, and then we slow it down. So if we were to send in, for example, 30, we would skip this part altogether and be doing this turn right, okay? So, because it would be less than, okay? And so we turn right until we get there, and this is what slows it down. So that's right turn, and notice we just call it right turn. We give it a number of degrees, and I'll show you how we tested that out in a moment. Let's take a look at the left turn. It's a little bit different, the logic behind it, and it took me just some taking it out on the course and practicing over and over. We got to reset the gyro just like we did before. We get the target heading, and this time, what we want to do is we want to, actually, I don't have to technically do this if we've reset the gyro. So actually, you could try it just getting rid of that equals negative degrees plus 3. Okay. If you need to, just put 0 minus degrees plus 3. However you want to do it. Okay, so point is this should work as negative degrees. If it doesn't, add a 0 to your calculation. But you're basically getting the gyro heading. We're subtracting 3 degrees, but we're adding 3 to cover that overshooting. Remember, we're going to the left, which means we're going down in degrees. So we're turning left as long as it's less than or equal to, or we keep repeating, excuse me, because we're going to start at 0, we're going to be going down in negative until, we repeat until we're either equal to or less than the target heading, less than being a greater number. So if we said we wanted to go left negative 180 degrees, now let's just calculate it out. It would be like 0 minus 180 plus 3, so it'd go till minus 177. And as soon as it hit 177, negative 177, or negative 178, or anything greater, or lesser, excuse me, lesser, then we stop repeating. And until then, If it's greater than the target heading plus 30, so negative 80, so great if the target is greater than negative 147, if we do the math, then we turn left at 10 degrees, 20% power. Otherwise, when we're within that 30 degrees of a target, turn left 2 degrees, 10% power. It's pretty much the same thing, but you do have to take into account we're working from 0 and we're going down in numbers. Okay, I haven't tested it with 0. I could do that. There you go. Okay, so what I did is I went ahead and I just put a negative degree instead of putting get gyro, subtract degree plus 3. Take a look at what else I did. I added this new function called drive forward, where I just give it a distance, and then I took that forward and I put get degrees, I add distance here, and so this, we can make it now where we just say drive forward 14 means drive forward 14 inches. Or you can do it as centimeters, because honestly, you decide how you want to. Just make sure whatever you measure it correctly. And so it will work whatever number you get, because the whole point is you're taking diameter. As long as you're using the same unit of measurement, you're good. Drive forward, so I added that little piece there. One extra code, couple extra lines here, and you may think, well, that's just kind of silly that we'd have another code. I could have combined these two together. I chose not to. But take a look at the code on here now. Now it's just drive forward 19, right turn 90, drive forward 10.5, right turn 90, drive forward, etc. And now it's a lot more readable. It's a lot easier. I just think in terms of how many inches I want to go. And I can measure that out and run it. But I went ahead and tested it, and it worked just fine. All right, so good luck. Why don't you try that yourself? Like I said, writing functions, it can be a little awkward at first, but this is definitely worth the time going into Robot C and just writing out your full function here. So I'm going to leave you with the right, I'll leave you with the left turn right here, and we'll just pause there and finish the video. So thanks for watching. This is the end of my series. Good luck with your maze challenge and whatever other challenges you have.